Good evening, participants. Welcome back to fifth day of Chapter 1 training topic on application of machine learning algorithm using remote sensing satellite images. So before we start, please do ask your questions in the chat box of YouTube Live, and at the last of session, so, Google form will be circulated for your attendance. Kindly do not forget to fill that, and there will be a announcement regarding exam on Sunday. So at the last, so kindly listen that carefully. Over to you, Kaviraj sir.
Yeah, thanks, Subham. So today is the last class of our entire series of Earth Engine algorithm and applications. So today we will discuss some of the use cases of Earth Engine where we can utilize it, and I will be showing you some of the use cases where I have implemented the remote sensing part using RF model or other machine learning algorithm one by one. And please do ask questions regarding this entire series. Whatever doubt you have, you can ask in this class. So let's start. Just a second, I will share my screen. So I hope my screen is visible to all of you.
Yes, sir.
Yes, is it visible?
Yes, sir.
Yeah. So during the entire training sessions, we have the first day we have given the general introduction of Google Earth Engine and some basics about the remote sensing. And then second day we have gone through some basics of Google Earth Engine and how to import the satellite image and displaying those things through examples. And the third day we have seen the visualization part and some of the basics of different machine learning algorithms such as random forest, then support vector machines, then classification and regression trees, descent trees. So those are some of the examples of machine learning we have learned, the theory part. And the fourth day we have learned the practical part and demonstrations of RF model. And now today we will be seeing some of the case studies, and finally we will take the questions and one by one I will try to answer. Okay. So let me share my screen again. Yeah, is my screen is visible?
Yes, sir.
Okay. So yesterday we have seen some of these examples of, we have gone through these practical demonstrations. So what we did, we have called the function called mask to cloud. This only will work in case of Sentinel-2, because this is only applicable in the case of Sentinel-2, not for Landsat and all. Okay. So be careful for this function while selecting the satellite image. Okay. And after that, this function we have called a variable for this image collections of Sentinel-2's SR product, and then we did a filtering of date through dot filter date, and then we have given the start and end date. Then we have filtered it by the cloudy pixel percentage, and after that we have masked the cloud through this function called mask to clouds. And after that we have selected the bands. So it depends on you what are the bands you want to select for your study. So it may change for different users or researchers. It depends on the objective, what particular thing you want to find out through the machine learning algorithm. So these are the band I have selected, and this dot filter bound is something like it will take the satellite image around your region of interest alone and eliminate the other area. Okay. So after that we have created a variable for visualizing the satellite image, and there we have created a dictionary, and in that we have mentioned the minimum and maximum value and then band detail, right? And after that, the entire image collection, whatever we sorted out through this filtering technique, the remaining all the collections we have, uh, we did a median filtering again. So this will create a median value of all the tiles. So this is actually a calculation, so statistical calculation to reduce the darkest pixel and brightest pixel in your image. So this is also kind of pre-processing, we can say, right? And then finally you have clipped the satellite image through clip and ROI. This is the function we have used. And now today, and after that we have collected our samples or called ground control point, and those things are like water body, agriculture, and then built up or something like that, forest, vegetation, and then bare land. And finally we have merged it all into a single variable called class LULC. So it can be anything, you can rename it according to your convenience. So through this dot merge option we merged all the training samples. So whatever samples we have collected, those samples. Okay. And then we have randomly distributed the samples. And after that, we have created a variable called training GCP and validation GCP. So here we are separating the entire data set or samples into two. One is training samples and one is testing sample or validation sample. And here it depends on you how much percentage you want to keep for training and how much percentage you want to keep for validation. Remember, 99% of the researcher are using 70% of the samples should be selected for training and remaining 30% sample for testing. So below 60% you should not go for training sample. If you go below 60%, then your model will consider is not a unique model, or you can say it is not a valid model. Okay. So you can go through various literature and you can see that none of the model has taken less than 60%. Okay. So it should be always equal or above 60%. So remember this particular point before running any model. And then remaining sample will come as a validation sample. And then after that, we have trained the model by training sample, right? So how to train the model? So we have taken the satellite image and then we have taken the sample regions and we have overlaid that on training GCP. So through this, we'll collect the band detail in our samples. So each band will get a detail or attributes through this function. Okay. So this is actually overlay function through which we are extracting the value of each band. And then we are training through a classifier. Okay. So our classifier is random forest classifier and we have given number of tree as a 20 and then we are training the model. So how to train the model? So we have to put some of the feature name or class names like features. We have to put the training features and this training goes to here, the entire thing. And then we need to mention the class property which we have mentioned here, a level or some of your case it will be LULC or some other thing. And then input properties will be always your sentinel to imagery with dot band names to include all the bands. Okay, so this band name will include all your band and this band name for your selection, and here we are putting anyhow for visualization purpose. So if you don't put this also, no issues. Here this is for visualization purpose and here it is for all band. So when you are putting empty, it means you are selecting all band. Okay. And then coming to the variable classified RF. So through this, we are actually running the algorithm after training the model through this classifier dot classify option, and our classifier is random forest, which is this one. And then finally we are adding that particular output to map, right? Up to this we have seen, right? Now coming to the next part for accuracy assessment. Okay, coming to the next part for accuracy assessment. So here we will try to find out test accuracy. So most of the literature or research article, you can see there will be training accuracy, there will be testing accuracy, confusion matrix kind of thing will be there all the time. Okay, so today we'll learn that part. So before entering into that, so we have to validate the model through, we have created a variable called validation, and on that validation part also we are taking the classified RF, which is the output from the model, and we are overlaying our samples on that. Which samples? Only the validation sample to check the validation accuracy. Okay. And finally, we are creating another variable called test confusion matrix, where we are putting this validation here, the entire thing, and then we are calling a function called dot error matrix, and there we are putting our label. Someone case label will be LULC or something, whatever you are giving during the collection of sample. So that particular attribute will come over here, and this classification will be by default, or you have to make it by default classification, since we are dealing with the classification because we are classifying the satellite image. In case you are searching for value, for example, what is the percentage of organic carbon, or what is the percentage of nitrogen, or whatever it is, if you are searching for values or unit, something like that, you can put here as a regression. So before putting regression here, the entire model also should run as a regression. But here we are running as a classifier. Okay. So that's the difference between classification and regression. In regression, we are trying to find out the value of each pixel. In classification, we are trying to find out the class of each pixel. Okay, that's the difference. So after that, we are trying to find out the confusion matrix of this particular validation samples. So here is the comment for that. And then we are printing both. So first printing will go, print comment for confusion matrix, and second one for test accuracy. Okay. So let's run this comment. So it's running. Okay, so we can see the test accuracy is around 0.86, which is 86%. Okay, and if you see confusion matrix, there is 6 element, right? So how many element we have? Starting from 0 and maximum 5. So that means 6, right? So it is exactly matching the same thing. And if you look into this in detail, so you can see it is coming something like this and something like this. So what you will understand from this, as I already explained in the first lecture. So the first one is showing 0. Okay, so 0 means whatever we have mentioned in 0 in the label. Okay, so 0 stands for water body or whatever it is, that particular value. So the total number of sample in that 0 as a, this is only validation sample, remember, first of all. Okay, this is only validation samples. The overall this things is confusion matrix belongs to validation sample, not training sample. Okay, so in that we have already separated our samples into two category. If you remember, training GCP and validation GCP, right? So we are only dealing here with validation samples. So which is 40% in this case, because 60% we have taken as a training sample and 40% for validation sample. Okay, so here only 40% of the total sample. Now if you look into the first one, it is 0. So 0 means whatever you put as a 0, so that particular class, here maybe it is water body, maybe the 1 belongs to the built up, or the 2 belongs to agriculture, or likewise it is there. So 0, if you see the zeros, the total number of sample is 10, and out of 10, the 10 sample is correctly classified as 0. The remaining is 0, 0, 0. So that means it's 100% test accuracy for 0 class, for the class 0. So it may be water or whatever it is you have given. The same case, if you see the 1, so how many samples are there in the 1? So 4, and then 6, and then 8, and then 9. Total 9 samples. So out of 9 samples, 4 sample has been correctly classified, and the remaining 5 sample is misclassified, right? So total sample divided by correctly classified sample into 100, if you put that test accuracy in percentage class wise, it will come over here. Okay, and then the second one, if you see the second class number second, if you see 13 sample only we have considered, and out of 13 is correctly classified. The remaining is 0, 0, 0. So that means all the samples has been correctly classified. The same way for 3, the same way for 4, and the last is 5th. In 5th, if you can see, the last one is correctly classified, and remaining 3 samples is misclassified. And then overall test accuracy is something around this. Okay. I think this particular thing is correctly understood by all. Okay. Now coming to the next part. So up to accuracy assessment, we have finished it. Now coming to the next part. Now we have satellite image with us, we have output with us, but we don't know what is the area of that particular. Each class wise area we don't know, right? So how to calculate area wise, class wise area, okay? Class wise area. So we have 6 classes, 0 to 5. Now if I want to evaluate the area of each class in a square kilometer or maybe in a square meter or whatever it is, so how to calculate that, right? In this it is not there, I will show you. So this calculation will be same for all the cases. Okay, this calculation of area, it is universally same only in Earth Engine. So where it is, I need to check it. Not here. Okay, so it is here. Okay, this is area in a square kilometer. So how we are actually calculating the area first of all. Okay, so entire thing is here. Image area calculation. Okay. So here you can see the maximum number is 3 and 0. So that means 4 classes, right? 0 to 3. And the same thing here you can see urban, water, bear and vegetation, the 4 things. So first of all we'll run and check how it works. Okay, and so it's working, and then you can see how it is, how we can calculate. So first of all we need to create a variable, and it can be anything, it depends on you. And in that we have image dot pixel area, and those things will be available if you search in doc, it will be there. So dot image pixel. Okay, so image will be, I will be in caps, remember. Okay. Image dot pixel area, a in caps. So here, okay, so what it is saying, suggesting, generate an image in which value of each pixel in the area of the pixel in square meter, right? So this will only give you in square meter. Okay, so if you put this alone you will get in square meter, but I want to calculate in square kilometer. So to convert the square meter into square kilometer, you need to divide by 1 million. So 1 million will be written something like this, 1 then E6. So there will be 6 zeros after 1. Okay. So this to comment for converting the square meter to square kilometer. Okay. And then which particular image you want to calculate. So that you have to add over here. So dot add bands. Now I'm adding that. So this is the thing, right? I hope it is clear. Then coming to the second part, up to this. Now we are creating another variable called area, where we are adding the previous one variable calculate area, and we are putting reduce region. So what is the function of reduce region? So for pixels or millions of pixels in each class, right? So maybe I have 100 or 1000 pixels in class 1, and likewise in class 2, class 3, and it may not be same in all the classes, right? So what this will do, it will try to group together. Okay, it will try to group together of each class, and it will create a region. So that's the function of reduce region. Okay, and inside reduce region there will be a reducer. Okay, this only will reduce or cluster, but how, what is the methodology to cluster? So that will be inside the reducer. Okay, so in this case reducer is ea reducer dot sum. So what it will do, it will sum up all the pixel belongs to each class. So for example, I have 100 pixels uh, inside a class, for example agriculture. So what it will do, it will sum up all the pixels. So 1 2 3 4 5 6, like that, 100 up to 100 it will go, and it will sum up all the pixel of each group. So that's the group, so each class, and then it will try to merge it into one. That's called group 1, and our group name is classification. This is fixed for classification approach. And then geometry we know already, ROI and scale we need to fix it. It is 30, or whatever pixel size you will give here, based on that you will get the pixel area, and based on that your this also will change. So that's the thing. Okay, so see, this many things maybe a programmer won't able to remember. So what you have to do, you have to check this one, dot reduce region. So what we will do, we'll try to check what is this. So reduce region, and inside the reduce region we can see here what they are saying. So reduce regions and reduce region. So there is a change S, and here is this one. So we are dealing with this. So what it is saying, to tell me which image I want to reduce. Then tell me the reducer, whether it is sum or whether we have to multiply or plus minus. What is the reducer? Okay. So by it is we have this also we have to mention, but geometry it is null and default to the footprints of the image first band. Okay, and then scale, by default it will be null, but we have to put it into meter. So we have added the scale as a 30. Then projection. So these are the things we have to mention here. Okay, so these are the things are here. Now another variable class area, where we are creating a list. So you can see this list in the right side. So this list, because of this list is here, so we are creating this list first, and then only it will appear over here, otherwise it won't appear. So we are creating a list, EE list. So through this only we are able to create a list inside Earth Engine. So EE stand for Earth Engine, and then list, and we are trying to create a list of this area, right? This area, and dot get the groups, right? So groups are here, we have mentioned already. And then we are telling the, please give me the print of that particular list of groups. Okay, here is the group, you can see dot group. So the entire group, it will come here and it will generate a list. So if you run it, and you will get something like this: 0, 1, 2, 3, 4. And if you click on 0, you can see sum. It is giving sum because we have used a dot sum, right? So it will give us sum. And this classification belongs to, we have already given the classification also. So this classification also is coming. So which particular classification it is belong? It is belongs to 0. And the total area is in a square kilometer. Now it is in a square kilometer. Okay. So this way, this entire things will work. So now we have learned the validation, how to calculate the validation accuracy, and then how to calculate a image area in Earth Engine. Okay. So if you have any questions for today's class, you can ask, or I will finish for today's class. You can ask if you have any doubt from the first day to the last day. Session is open for question. Shubham, are you there? Okay, Ajay, we can take one by one question. So what are the question? Yeah, one by one we can take.
Hello, sir. Am I audible?
Yeah, you are audible.
Sir, in the chat box, there is no questions now.
Okay.
Hello, everyone. If you have any questions, so please ask on YouTube chat live box.
If you have any doubt from the day 1 to the day 5, you can ask any questions. Or if you have your personal question also, you can ask me regarding what are the portion you are working on, and you are struggling. If somewhere you are stuck, you can ask me that question as well. I will try to answer it. And if you are trying to explore somewhere in Earth Engine or some portion of Earth Engine, that also you can ask.
Yes, sir. We have got first question. The question is how to synthesize primary data in the context of vector scale.
So what do you mean by primary data? First of all, I need to know. Primary data means whatever we are collecting, that GCPs, right? So in the context of vector scale, so in the case of vector scale, if you are trying to synthesize, what do you mean actually in this question? I don't understand. Can you elaborate it?
Sir, we have next question. Sir, how to find the volume of water in any water bore or any pond or tank?
So see here we are not dealing with high resolution satellite image. So here is a problem. So what we need high resolution satellite image where we can get the depth, or where we can like area we can get it, but for volumetric analysis we need a depth also, elevation, right? So that part, if it is there, then we can do it. So we have a formula to calculate the water volume, or we can say that way, and that particular thing, that formula we have to write in Earth Engine, and definitely it will generate you the output. But for that we need a proper data regarding the depth of the water body. So you can put as a average depth of a particular water body from SRTM image. If you try to do it, is very difficult because it will not give you accurate result. So try to get some kind of drone imagery, and you can import that particular imagery, and then only it is possible, I guess. Okay.
Yes, sir. Dear participants, if you have any questions, please ask. Sir, the next question is from where we can download the high resolution satellite data.
We can't download data which is not available. Some of the things are like up to 20 meter we can download, but we don't have below 20 meter, we have to buy it. Okay, so it's not open source, you have to buy it. And if you want to buy, we need permission. Below 1 meter we need permission from the government authority, and from 5 to 1 we no need to get permission. So if you give an order, you will get it. You have to pay for that.
And sir, he also wants to know about DM data, any website.
Yeah, there is a website for Indian satellite. We can directly get it from Bhuvan. So we have Bhuvan in there. If you go into the Bhuvan, there will be a link. Through that link, you can ask for data, and they will revert you within 48 hours with the detail, whatever satellite data they have. Okay, but in case of this data, like depth related data in abroad, not India, like we have ISRO data, but if you want to order from abroad, so you can order from Land Viewer. There is a website called Land Viewer. From there you can order.
Yes, sir. Sir, the next question is, suppose I have fetched some primary data for flood susceptibility mapping. In that scenario, who can we put that in the vector scale?
So you are trying to analyze the flood successfulity mapping, right? So if you want to do some kind of flood related things, so what we can do in that scenario, who can we put in the vector scale? Can we take that person in line, or that's not possible?
Sir,
Still the
I think
question is not
this
clear.
time this is not possible.
Yeah, I need to understand the question actually. What he is asking, I don't understand still. See, if you are trying to map flood successfulity area, you should have primary data, and the second thing is you should have elevation data. Then the third thing is you should have secondary data for like historical flood related data, and then drainage data. These are the data we need to, first of all, you should have. Okay, so to run the model to map flood successfulity areas or zone or region, whatever it is, we need, these are the things. So first of all, through the elevation data we can create aspect, we can create aspect and hillside, and then We can generate DAM for terrain, and then we can generate drainage network, drainage density, those things we can generate. Resolution
Dear
of the data.
participants,
Resolution of the data in vector, it is in vector there will be no resolution. It is only scale, 1:50,000 or 1:60,000. Okay, that is the scale it is asked.
sir, we are sharing the Google Meet link on chat box. So if they have
Yeah,
questions, so they can join to meet.
yeah, that
Dear
will be better.
participants, we are sharing the link of Google Meet. Please join on Google Meet and ask your questions one by one.
Okay, please join that. So in the case of vector data, there will be there is no like scale, just that is RF, call RF. Okay, so 1:50,000, 1:60,000, like topos we are getting 1:50,000. In resolution comes in like when we are using satellite data, so that is spatial resolution. So Bhuvan website resolution data, it will be around 2.5, 0.5. Likewise, they have 0.5. I think they don't have 2.5 to 1, up to 1 meter you will get. That's the resolution. For detail, you can go Bhuvan website and try to search from there. You will get the detail.
Dear
Yes, any other
participant,
question?
we have shared the Google Meet link. If you want to directly ask to sir, you can join on Google Meet. Hello, Mega.
Yes, Mega, you can ask question. First, unmute yourself. We can't hear you. Mega, please unmute yourself and then ask question.
Sir, we got another question on live chat box, YouTube live chat box. The question is, I have one doubt regarding the Google Earth Engine values extraction. I have given data duration 4 months from Moody's data. I have calculated NDVI from those data, and I want to extract NDVI values of points.
Yeah, we can do that. That functionality available in Google Earth Engine. We can extract the satellite data using point feature. That values are there. That facilities is there. So there is a tool. I didn't remember, but it is there. Okay, I will just check and I will tell you just a second. If you have any other questions, you can go ahead with that question, and manually I will try to find out that particular.
Sir, the next question is, if
Yeah.
in 4 months 8 images showing, but any one data values is missing in CSV.
If in 4 months 8 images showing, okay, but any one dead values is missing in CSV. So 4 month 8 images is visible, but any one dead value is missing. Okay, any one dead that image is not there, is missing in CSV. Then what? Then what you want to say? What is the question? Please come and join in the link provided by GeoVigyan team.
Dear participants, if you have any doubts and you want to ask in Google Meet, So we have already shared the Google Meet link. Please join that link and ask your questions here. Level of satellite data. Actually, sir, I want to know the resolution.
Yeah, Ajay.
Sir, am I audible?
Yeah, your voice is breaking little. What is that? What is that question?
Sir, the question is, what is the meaning of satellite data? Actually, I
Sorry, Ajay, I can't hear you.
the meaning of 20 levels of satellite data. Sir, I want to know the resolution.
20 level of satellite data. 20, not 20 level, that is 20 meter. That is 20-meter resolution of the satellite. Okay, for if you want to, if you are from non-remote sensing or non-geoinformatic background, please find out the types of different types of remote sensing satellite imagery. In that you will get one spatial resolution, and that is called the pixel size of each the each pixel size in a satellite image. Okay, and that each pixel size is 20 meter. So that only I said, that is not 20 level, it's a 20 meter. Okay.
Dear participants, if you have more questions, please ask on Google Live chat box, or you can also join our Google Meet link, which we have already shared. Sir, I think there is no more questions.
Yeah. So if there is no question, we can wind up. And still,
Yes,
if you
sir.
have any question, you can ask.
Sir, there is one question in Google chat box. Sorry, Google Meet chat box.
Okay.
By the help of machine learning, can we do mineral exploration?
Yes, we can do that. So for mineral exploration work or those kind of project, first of all, we should have ground data. So we should have the location of that particular mineral in a particular study region. So go there and try to uh, take the coordinate of the particular mineral, and if you have better instrument, you can take the wavelength of each band in the ground itself. That is also one kind of data you can get it. And if you don't have that kind of instrument, no issues, you can just take the measure this one coordinate alone and try to get as much as possible points. And also you need to find out the literatures related to mineral, right? So literature related to that particular mineral which we are looking for to map. So that will help you in finding out the proper parameter which they have used for their research, and they have found that these are the band or these are the spectral indices can be useful for that particular mineral exploration. So that will help you in finding out the parameter which you will be needing for that will be needed for your fixing the parameter in random forest model. Okay, so in our case I have showed you in when I have showed you the land use land cover classes, this one prediction using random forest. Remember that we have selected only the spectral bands of sentinel-2, right? So except that band, we can also use spectral indices, not only band. So band is already there, but again if you want some other parameter like spectral indices or some kind of elevation data or some other satellite imagery data, that also can be a variable in that case. So those variables you have to list it out. So for example, I can show you, just a second. So for example, so you can see here, I hope my slide is visible, my screen is visible, right?
Yes, sir.
Okay, so I have indices. So this all come for
Sir,
through the
sir, your voice is
particular
breaking.
quantity, whatever. Yes, yeah, my voice is breaking. No, you are audible to me. I don't know about my voice. No, my network is full. Yeah, am I audible?
Yes, sir. Now it's fine.
Hello.
Yes, sir.
Okay, so you can see here we have created various variables. So each variable will have different formula, and after that, these variables will come as a predictors. Okay, so you can see I have created another variable called predictors where I have added all the bands, and then I have added all the indices. So likewise, if you have different kind of algorithm, that also can be calculated from here, and you can assign a variable, and finally you can add it as a predictor. Okay, and this predictor will finally help you here. So while training the model, you can see here we have added predictors. But in my previous class, I have showed you only sentinel-2, right? But here we are putting predictors. So predictor includes sentinel bands as well as all indices and likewise. Okay. Yes. So likewise you can do for mineral exploration. Yes. Any other question?
Yes, sir. He also wants to know if we don't have any particular point data, what?
If you don't have particular point data, then refer the data given by government agencies. That is the secondary data, you can take it. Otherwise, that also if you don't have, you can go to the WUCOS. There is a website called WUCOS. There we have minerals and all mineral deposit locations. Whatever Geological Survey of India survey has been carried out, those locations will be there in WUCOS, BHUKOSH, WUCOS website. Okay, go there, see the mineral, what are the deposits, wherever it is located, take those data, and then you can do the analysis. Okay.
Yes, sir. The next question is, I want to analyze the development of a particular area using satellite images. over the years. For example, from 2001 to 2023, to understand what changes have occurred. How can I go about doing that?
Okay, so if you attended my, I guess, second class, so I have showed you how the thing has changed. Like, I think it was regarding the water body change. So first of all, we need to calculate for 1 year, and then we have to go for the second year. Then we can put the first year minus second year, and then the changes will come. Okay, and that will be like dependent on a particular spectral indices, or that can be depending on the classification of image. It can be land use land cover, it can be based on some spectral indices changes. So changes can be many types. Okay, so that way we have to do. So first year minus second year. So first year maybe 2000, the second maybe 2014, or you can take whatever you want. So that way. So before flood, after flood, then before industrialization, after industrialization. So likewise we can do lot of calculations. Yeah, what is the next
Sir, the next question is, sir, can we join the Sentinel-2 data with Landsat for time series data observation?
Yeah, definitely. You can take whatever data you want, but remember the scale supposed to be same. If you are taking Sentinel-2 and if you are taking Landsat series data, then remember Landsat Sentinel-2 is 10 meter, and then Landsat is 30 meter. And remember, while doing the analysis at the final stage, your both the data should have same spatial resolution. So you have to do the resampling. So there is a tool in Google Earth Engine called resample. So there you have to put resample for Landsat for Sentinel-2. So Sentinel-2, you have to do the resampling to 30 meter, and then you have to do the time series analysis. Otherwise, it won't be logical. Yeah, Ajay, next question.
Yes, sir. The next question is, uh, how can we take DOI for multiple years? As DOI is known for single years only, how can we take for multiple years?
DOI here, date. What is DOI?
It's not clearly mentioned, sir.
It may be date. You can take
Yeah,
date for
maybe.
it can be date. Okay, maybe date. So
Yes,
how
sir.
we can take date for multiple years as date known for single year? Okay, in this case, see, in this case we have to take a particular season, or we can say particular date. Likewise we have to take. It is not like we are taking the entire year satellite image and then combining to the, it is a huge task, and your Earth Engine will not respond to your analysis. Okay, so either you have to focus a particular an annual satellite, annual imagery is also available. If you see the Earth Engine, there will be a data option where you can see the Landsat annual NDVI, those kind of data is available, but annual satellite image will not be available. Okay, so in that case, either you have to select a particular week or particular date or particular season or month. Likewise you have to select.
Yes, sir. The next question is, sir, it's out of course question. Actually, I have 1 meter of satellite data as well as 13 meter of DM. I want to know how I can check the accuracy of that data method.
See, to check the accuracy of any satellite, not only 1 meter, 30 meter, or micro centimeter or centimeter, whatever it is, to check any satellite accuracy, you should have ground level data, which will come through DGPS survey or GPS survey. So first of all, do the ground level survey, and then you have to take those ground control point into the map, and then you have to find out the shifting. So how much it is shifted from each point, and finally you have to take the mean value of each shift, and thus we can, through that you can calculate the error. Okay, so that is one point. The second point is, if you have finished the survey, now you are overlaying the points and you are seeing that there is a huge drastic change, then how to handle the error? Okay, in that case, what you have to do, you have to geo reference again, that is geo rectification, and those things you have to do again. So the displacement of satellite image will get removed after that. Okay, through triangulation method. There are a lot of methods in georeference as well. Okay. Yeah,
Yes,
Ajay.
sir. There is no more questions, sir. Dear participants, if you have any questions, please ask. Otherwise, we are ending this session. Till then, I want to announce about exam. Those participants who have registered for examination of that this training, please note that on 15 8 p.m. You have your exam. You will get the exam link via through email, and please go through our website geovigyan.com. All the rules and all the details are mentioned there regarding this training and exam. Sir, I think there is no more questions, so we can bind this session.
Okay.
Yeah, thank you, sir, for this training and your valuable time and knowledge.
Thank you to GeoVigyan team for arranging a wonderful training session for all.
Sir,
Thank you.
we have
Yeah.
got a question.
Yeah. Yeah, Ajay, saying something?
Sir, what is the procedure of DM resolution change if it is?
Sir, what is out? Okay, it's out of question. Okay, actually, I have 1 meter satellite. This already I have answered.
Yeah, this is taken. Recently, we got a question in live. What is the procedure of DM resolution change if it is?
See, if you have 30-meter resolution of DEM image, and then if you are resampling it to a 10 meter, so 30 meter to 10 meter is not at all logical, or it is a downscaling. So downscaling data will never change. It will be remain same. Okay, so always you have to do upscaling. So like you are going to convert 10 meter to 30 meter. In that case, you have to resample the image 10 to 30. So there is a lot of techniques available for resampling for as nearest neighbor. Then we have clustering technique. One technique is there, so it will take the nearest pixel and then will try to cluster, and there will be maximum, minimum. Likewise, there are a lot of techniques. So then there is interpolation also there available. Through that also you can do the downscaling or upscaling. Both are possible. Okay. In Earth Engine itself, we have 3 to 4 processes. Just go how to resample a satellite image through Earth Engine, you will get the detail.
Yes, sir.
Okay.
Dear participant, if you have any doubts about exam, the exam is about 30 questions. Sorry, 25 questions of 2 marks each, total 50 marks, and you have to pass at least 60%. You need at least 60% marks to qualify for the exam certificate. And you can also go through our introductory video. We have given all the details there. Yes, and now we can bind this session. Thank you, sir.
Okay. Thank you, Ajay. Thank you.
Yeah, thank you,
Thank you,
sir.
GeoVigyan team. Yeah. Thank you.
Participants, we hope this training will definitely benefit you in your future. And please go through our introductory video or geovigyan.com for exam details. Thank you all.